But let's go look at a slightly more interesting example, which has a very similar structure. But now when we're selecting GPUs, we're not just going to select a single target locale. We're going to select a target locale which has multiple. So we have an array of locales. And so here we're either going to use all of the GPUs that are available to us, or we are going to use as many of the current CPU as we can. So the number of locales is going to be equal to the number of CPUs. And this isn't really necessary to get parallel CPUs, but it does make our code a little bit more concise when we're trying to target both CPUs and GPUs. So our target locales is either our GPUs or CPUs. And we can then declare our array on the CPU. And then we get into those coforals that Engin was talking about. So what this coforal is going to do is for each iteration of this loop, so for however many chunks there are, it is going to create a task and do something in parallel. So if n chunks is 10, each iteration of this loop, which will be 10, will happen at the same time. And then in each iteration of the loop, we'll go to the current target locale that we want to look at, and we will get a chunk of memory, and we'll do an increment on it. So this is kind of a very low-level way to initialize each segment of our array, our host array, to be essentially the number of the locale. So either the ID of the GPU or the ID of the current task that we're on. So if I run this program, and I'm going to run the CPU version first, which all I need to do to get a CPU version of this program is recompile with a different flag. And if I just print it out, you'll see that the numbers go up to 64 because there's 64 cores on this machine. And if I run with verbose GPU, nothing extra is going to print because we didn't run this with any GPUs. So now I can switch to using the GPU on this system. And if I just do a print, see, it's not the most interesting output because, again, there's only one GPU on this system. But we can confirm that, GPUs are doing something with verbose GPU. We can see this copy from host to device on line 28, right? So we're taking our host array, we're copying it into device memory, we're doing our computation, and we're copying it back. So let's go ahead and switch to a little bit more interesting example on a node on AWS with 4 GPUs. So give me 1 second. Awesome. Okay. So like I said, the exact same code, but now it's been compiled for NVIDIA with 4 GPUs. So if I run this exact same example, except you can see now the file name has NVIDIA in it because I've compiled it for NVIDIA. And I run it with verbose GPU and print. So now there's a lot more kernel launches happening, and we can see that the ID has gone up to 4 because there's 4 GPUs. And if we look here at all these different kernel launches, individually, there's still that same host to device launch and device to host transfer. But over here, we can see exactly which GPU is doing the work. And so we've now got 4 GPUs doing the work.